Let's do 7 segment display decoder in this presentation. On your screen you can see that there are two images. On the right hand side the image shows you the actual display which you will get in the market, okay, and there is 7 segment in this display. This is the first one, second one, third one, fourth, fifth, sixth and seventh, and also there is a decimal point here. And all of this, the 7 segment and the decimal point, is illuminated by LED. Individual LED is associated with this segments, and depending upon the condition, depending upon the input and what they have to display, the corresponding LEDs glows, okay. On the left hand side you can see that we are displaying from 0 to 9 using this display. On the left hand side you can see that we are displaying the numbers from 0 to 9 using this display. So for an instance, let's say I want to display the number 1. So for this I have to illuminate these two segments, and one more thing we do is to give each segment a name. Let's say it is A, B, C, D, E, F, and the middle one is G. So to display 1 by using this display, we have to make B and C high, okay. So there is one thing you already know, that 1 is represented as 0001 in the binary world, and all the digital circuits work on the binary numbers. So this 0001 is somehow to be converted in something which illuminates the LEDs of the segment B and C, and the intermediate thing which decodes this 0001 we call as the decoder, the 7 segment display decoder that you can see here. There are 4 bits, B0, B1, B2 and B3, that represents your number from 0 to 9, and this is your 7 segment display decoder, and that is what we have to find out in this presentation. It is nothing but the combination of the logic gates which decodes this incoming signal to the signal which makes these segments high correspondingly. So let's move to this one. Now here you can see that a table in which I have written the BCD codes, and if I want to display 0, then it can be done in this way. You can see here it is displaying 0. So to display 0 we are having the segments A, B, C, D, E, F as high. The LEDs of this segment should be high to display the number 0. So what we will do, we will make them high. So A is high, B is high, C, D, E, F, C, D, E, F are high, and G is low. So G is 0. Similarly, if I want to display 1, in this figure you can see that how 1 is displayed. So to display 1, the segments B and C are high. So we will make them high. A is low, B and C are high, and all the rest segments are also low. Similarly for 2, if I want to display 2, then segments A, B, D, E and G are high. So we will make them high. A is high, B is high, D, E and G are high, F and C are low. Similarly for 3, A, B, C, D and G are high. So we will fill them in the table. A, B, C, D, G is low, F is low, and E is low, F is low and G is high. Similarly for the number 4, B is high, C is high, F is high and G is high. So B, C, F, G, rest of them are 0. Similarly for number 5, we are having A, C, D, G and F as high. So A, C, D, F and G, and rest of them are 0. Now we will move to the number 6. For 6 only B is low and rest of the segments are high. So only B is low and all of the other segments are high in case of 6. And for 7, A, B, C are high, A, B, C are high, and rest of the segments are low. For 8, definitely every segment is high for 8. And for 9, only this segment, this one which is our E is low and each and every segment is high. So A, B, C, D, E is low, F, G. So and the cases in which the numbers which are greater than the 9 are the don't cares. Why? Because if I want to display 14, then I cannot display 14 by using a single 7 segment display, but I need 2 7 segment displays. One will represent, the first one will represent the 1 and the next one will represent the 4 in this way. So I need 2 7 segment displays to represent 14. That's why the numbers 9 onwards we take as the don't cares. And I hope you now know how to make this table, and by using this table we can easily minimize the function for A, B, C, D, E, F and G, which are our 7 segments. And how we are going to do that? We are going to do that by the K map, Karnaugh map, which we have already discussed. So in the next presentation we will minimize them and we will see what we are getting, and the combination of all the functions that we get after the minimization is our decoder, and for that we are doing all this work. So see you in the next one.